with respect to the discrete type, where we have a input 1, 0, as well as it's a function of a xjk. I have told you what is the meaning of a xjk. It's the activation value of the jth neuron at the kth moment. I have told you how it is read also, and what is the physical interpretation of the same. Kth instant. That is how we are going to write. If the same thing is written something like xi with the k plus 1. What is the meaning of it? It's the activation signal of the ith neuron at the k plus 1 instant. That is the meaning of the xij. That is what is with respect to the discrete. Now even we have seen a linear threshold signal where it will have a variation of its signal function, which is like a ramp, which is increasing as the input varies, or it will decrease as the input decreases. So that's how we are going to call it as the linear threshold signal function. And here we had seen even one more term, that is the alpha j. The meaning of alpha j is the 1 divided by xm. Alpha j we are going to call it as a slope, and it is dependent on a value of a xm. xm is variable. We can take it 0 to 2 or 0 to 4 or of your choice. So depending on the value of a xm, the value of a slope is going to change. And this also we have seen how is the value of a theta is going to affect the slope. It is going either to shift it to the left or to the right, depending on the value of a theta j, whether it is plus or a minus. Then we have seen a sigmoidal function, wherein it will have the value of a lambda here. Lambda is called as a gain scale factor. As the value of a lambda increases, then the smoothness of the sigmoidal function is going to reduce. If the value of a lambda tends to infinity, then the whole thing, the sigmoidal function, will get transferred to a, can you tell me which one it is? If the value of a lambda tends to infinity, what will be the type of the signal function? I have told you in the last class. Is anybody?
Non-smooth binary threshold.
Yeah, correct. It's right. It's going to change to a binary threshold, whatever we studied, which is something like this. Earlier it is a sigmoidal function, but as the value of the lambda changes, it changes to a binary. Is that clear? And we have seen even with a change in value of a theta. The next one is a Gaussian signal, which is most widely used in many of the applications, which has got two terms over here. The one is a spread factor, which we are going to call it as a sigma. You should know the notations also. You should have a value of a sigma. The sigma is termed as a spread factor. It is a spread factor, and we have one more term, which is a Cj, which tells you about the center of the Gaussian signal. As the value of a sigma is going to vary, then what will happen? Varying the value of a spread factor, what is going to happen? You can see from the curves of a Gaussian signal, the innermost curve is for alpha is equal to 1 and the outermost curve alpha is equal to 3. What do you make out from that? It indicates that as the value of alpha is going to increase, then the spread of the curve is going to diffuse, or the spread of the curve is more. If the value of alpha is less, then the spread of the curve is less. The next, coming to the next topic of it, it's the architecture, feed forward and feedback. Look here, I'm going to just give you some time. Copy this, then I'll start explaining. I have told you, write the today's date, then copy the figure. Why I'm making it compulsory is that at least you will have a one-time practice. So copy this, then let me explain you what it is. I'm just going to give you 2 minutes. Is it over? Hope all of you have completed. Let me start. Yeah, let me start explaining what is the meaning of a feed forward and a feedback. So the architecture of the neural network is categorized into two types. The one is the feed forward architecture, the other one is a feedback, or even it is termed as the recurrent. So let us see what is a feed forward as the name implies. What is the meaning of it? The meaning of the feed forward is wherein it's going to feed it to the next nodes and there is no formation of the loops. So let me tell you here the okay. Let me tell you here with respect to the feed forward. This is a figure with a feed forward. Let me just tell you what is a feed forward. Then we'll come to hetero associator later. What is the meaning of a feed forward? Whenever we consider any of the neural network, it will have a different layers. So this whatever the layer we have at the beginning, this is called as a input layer. And whatever the last layer we have is called as a output layer. Here the input layer is represented as a capital with a subscript of a X, and the output layer is represented as a capital F with a subscript of a Z. Now we do find one more layer in between. Here we do find one more layer in between, and this layer is called as the intermediate layer, or even it is termed as a hidden layer. So in a neural network, whenever you do consider, there will be three kinds of layers. One is the input layer, the other one is the output layer, and we do have a hidden layer. Now I did not tell you about how many hidden layers will a neural network contain. The number of hidden layers will vary. The number of hidden layers are going to vary. It may have only one hidden layer or can have more than one hidden layer. So this is what is the structure or the architecture of the neural network. That is the basic building block of the neural network. Now coming to the feed forward. What do you mean by the feed forward? As it is written here, has no loops. The meaning of it is the input layer, whatever it is going to get as a signal X, is fed to the hidden layer, and from the hidden layer it is fed to the output layer. Input flow from one direction to the other direction. We have Ix fed to the input layer, and next to the hidden layer, next to the output layer, and we are going to get a value of a Y. So here capital X is the input and capital Y is the output. In between we do have a number of layers. As you can see from this, it's clearly seen that there are no loops. What is being done here? In case of the input layer, which is represented as a Fx, we have a small ellipsis here. Can you see? We do have a small ellipsis. It indicates that each of this ellipse corresponds to a particular neuron. It corresponds to one neuron, and this corresponds to the other neuron, and so on. There can be a number of neurons within the input layer. Is that clear? So there can be number of inputs in a input layer. Now here we are not going to call it as the neurons. We are going to term these neurons as nodes. So input layer is going to have a number of nodes. When I say a nodes, it represents or it says that it has got so many neurons which are acting as, which are there in a input layer. So we do have number of nodes. When I say a nodes, it means that those many number of neurons. Now coming to the next one. Here it is a hidden layer. Hidden layer also will have a number of neurons, and we do have a number of neurons or the nodes even at the output layer. So each of the layer will have a number of nodes present in it. How many nodes to be considered here? That is left for the choice as an option to select the number of nodes in each of the layers. And for the feed forward, there are no loops, and that's how we are going to call it as the feed forward. Now when I mentioned that there are number of nodes which are acting as an input, how these inputs are represented? How these inputs are represented? When I see an input to say a AND gate, then we have input. Can you tell me what will be the input for the AND gate? What will be the input for the AND gate?
A and B.
A and B. How are you going to give? What are the values?
Digits.
What is the value? We are going to call it as
0 and 1.
Yeah, good. It's whenever you are giving an input to the AND gate, the inputs what you give is the 1 and a 0. Now, whereas in case of this neural networks, it will not be the 0 or the 1. It will comprise of a vectors. It will be the inputs, whatever you give, that is the X, it will have a vectors. Hope all of you can understand the meaning of a vector. It can be of any dimension, but the input that you are going to give is in the form of a vectors. Now, from the input layer, you are going to apply the input to a hidden layer, and from hidden layer to the output layer. Now, what do you expect at the output? Will it be in the form of a vector or something else? When I apply the input in the form of a vector, the output also has to be in the form of a vector, right? If I have written 1, 2, 1, 2 as the vector, I'm just giving you an example of the same here. If I'm giving an input as the 1, 2 and again a 3 and 1 as my matrix form as an input, the output will also have been found out in a vector form. Is that clear? And the signals that may pass through number of hidden layers will also be represented in the form of a vector. Hope all of you can understand the meaning of the vector. Is it? So here the same thing happens with the feed forward. We are applying X as an input, and the X can be in any state. It can be in any state vectors, or we can say that it can be in any vector space. Now if I write an input as a vector which is lying in a state space of hope you might have come across this notation in your mathematics. Can you tell me what it is?
Real numbers.
No. I'm asking in terms of the linear algebra. Linear algebra. Okay. If any of the input is lying in a state vector space, then we are going to represent it with a state space R to the power n. Now, if f is a function, f is a function of Rn, and the output will also have the another function. So what is the meaning of it? Here we have the same in a vector form, and this is also in a vector form. It indicates that if you are giving an input with some other dimensions of the vector with different values, if I take this as an input, if this as an input and this as a hidden layer and this as the output layer, then can you tell me how many nodes are there in the input layer? How many nodes are there in the input layer? Not layer. How many? Yeah, correct. How many inputs are there in the input?
3.
3 nodes in the input. Now we do have only 2 nodes in the output. Is it right? Now the number of nodes need not be same as that of the input. Okay, the number of nodes that are present in a input need not be same as the output. In the output we do have only 2, whereas in a input we do have the 3. Let me represent this with the 3. Here each of the neuron gets connected to the every node in the next layer. So the first neuron gets connected to all the nodes in a hidden layer. Similarly, the second node gets connected to all the neurons in the next layer. The next layer here is the hidden layer 1. Similarly, this also gets connected to all the nodes that are present over there. And here the number of nodes is in the output is less. So this is how we do have a neural network. Hope you might have seen the neural network which is drawn something like this. Is it? So from this, what do you make out? It's the feed forward, and here you can see that none of the output is fed back to either the hidden layer or to the input layer. So there is no formation of the loops. So that's why we are going to call it as the feed forward. The other thing with respect to this is we have the Rn transforming to Rp, the state space. Here we are going to call it as the hetero. The meaning of the hetero is which is going to be transformed from N state space to a P state space. Maybe with the 3, I'm just giving you a simple example, 3 neurons to the 2 neurons that are there in the output. So the value of a n is getting transformed to the value of a p. Such a network, neural network, we are going to call as the hetero, where the value of a n is not equal to p, where the value of a n is not equal to p. Now the other term, hope you might have understood now with respect to the hetero. I'll just show you the slide. That is, figure A is feed forward and hetero associator. You have understood the meaning of what is a feed forward and what is the meaning of a hetero associator, where it is going to have a transformation from Rn state space to Rp state space. Now what do you mean by the feedback? What do you mean by the feedback? What is the meaning of a feedback? Okay, let me move to another concept with respect to the feed forward before I go to the feedback. I told you that there is no formation of a loop, and one layer gets, the next layer gets the input from the previous layer, and there is no loop formed by any of the layers. In logic design also, you might have studied two kinds of logic circuits. Which are those? Which are those that you have come across in digital circuits or in logic circuits? You might have come across two logic circuits. Which are those? Yes. Tell me which are those. Have you heard about the combinational logic circuits? Have you heard about the combinational logic circuits?
Yes, ma'am.
Yeah, what does that mean? Combinational logic circuits where the output is dependent only on the present input, right? If you have a example of an AND gate, what do we have? We have a input. As for the AND gate is only with the if AND gate is represented, AND gate is represented with the two inputs and the output. We have the input as 1 and a 0, and this is a output. If input is 1 1, output is 1. If input is 1 0, output is 0, and so on. Now this output is dependent only on the inputs. It is not taking what is the previous condition of the output. So the output is dependent only on the present. So similarly, in case of the feed forward, the output is dependent on only the present input. So as you can see from the slides, that the present output is dependent only on the inputs, not on the previous output. Whereas in case of the feedback, the figure B as well as C are for both feedback. Again, we are going to differentiate what is a auto associator and hetero associator. We have already seen the meaning of the hetero associator. We'll come to know what is the meaning of the auto associator. As you can see from the figure, that here we have X and we have a Y, wherein there is a formation of a loop. So that is why we are going to call it as a feedback. Now what is the meaning of the auto associator? The output of the neuron is fed back to the same or to the neuron in the same layer. We have, how many nodes do we have? How many nodes do we have? How many nodes are present here? Tell me the answer. How many nodes are present in a figure B?
3, ma'am.
3, ma'am.
Good. It's the number of nodes that represent is 3, and you can see that the feedback may be to the same node, or the feedback may be from the node of the same layer to the node of the, that is from the same layer it is fed back to the other node. That is what we can observe from the slides. So here that is what we are going to call as the auto associator. Then we have the other figure which is written as the hetero associator. Can you explain? Can anybody explain what is the feedback hetero associator looking into the figure? I've told you meaning of feedback. I've told you meaning of a hetero associator. Now you need to club those two and explain what that figure corresponds to. Shirisha is there?